Perfect. So my name is Liukas. I come from Helsinki, Finland. I'm an author, an illustrator, a programmer, and a business school dropout, but because of our Scandinavian self-deprecating nature, the only thing I really feel confident about saying is that I'm a dropout. I co-founded Railscales in 2010 with Kari Saarinen. It was supposed to be a weekend workshop in Helsinki, nothing else, but to date it's been in over 227 cities, run by volunteers everywhere in the world, from Belo Horizonte to Berlin, from Amman to all the way here to Australia, and it's been amazing to see how the community has grown around that. After working on Railscales, I went to New York to work at Codecademy. I was a 5th employee, and I worked there for 1.5 years, and I realized that, no, I don't want to do startups anymore. I want to go home to Helsinki. And that raised a big question, what next? And I thought about my career in technology, and I realized that I had never been alone. I had always had this little savior with me. Every time I run into something that I couldn't understand, like what is object-oriented programming, what is garbage collection, I would try to think how a 6-year-old little girl would explain this thing. And I had enough of the startup zeal left in me that I thought about, like, what is the most scalable change, what is the most scalable change a person can do in the world? And instead of apps, I thought about childhood. Because, ladies and gentlemen, if we can affect the way kids see the world, we can raise a totally different kind of world of adults. And that's how I wanted to become a children's book author. There were only 3 problems. First being that I had never written a book before. I was a really, really bad illustrator, and I considered myself a really mediocre programmer with very little industry experience, no formal training in CS, and no industry or institutional knowledge of early childhood or pedagogy. But I decided that, okay, let's try it out, and I tried to look for the oldest Ruby pictures I could find, and these are from 2009, and you can see they are not very good. But I kept on drawing every single day, and slowly the pictures got better, and one of the things that really motivated me was seeing all of the other cities around the world making their own versions of Little Ruby and her adventures, and I even got these little plush toys from Brazil, and slowly the pictures started to become better. And then last January I made, in some ways, the best decision in my life, in some ways the worst decision in my life, and I put this project that was still a very tiny side project on Kickstarter, and in 30 days it was pre-ordered. $380,000 worth of pre-orders came in, and what started as a side project for Ruby parents all around the world became this massive thing to teach all kids computational skills, and this has been a year of heartache and crying and anxieties, and I wanted to kind of give you an idea how I've gone through this whole thing. And if there's a lesson here, it's that ideas rarely come out resonant and striking and beautiful. They look really messy and you have no idea what's going to turn out of them, but you still need to sort of lean forward and try. I needed help on this journey. I had this idea about a book. I had a little experience of teaching programming, but I still needed some sort of principles to help me guide this product development process. So I came out with my principles of play. And I'm going to talk to you for a second about programming and play, and then I'm going to introduce you the 3 principles that have helped me build Ruby's world. But before we get into any of that, I want you all to become, so all of the exercises that I mentioned over here are also on helloruby.com. They are all under Creative Commons license, so you can download them, you can modify them, you can see how they work, and you can also see what other kids have built around these exercises. But before I get to the principles of play, I want you to be Alice with me. I want you to take the red pill and fall deep down inside the computer. So here's where I started. After working for 4 years in the Learn to Code movement, and coding is the new literacy thing, I was left with this idea that if JavaScript is the new lingua franca, we don't need more grammar lessons, we need poetry classes. The same way as I, as a little girl, learned Finnish in school, not only through grammar, but also by reading a lot of books, by analyzing other people's writings, by writing my own really bad poems and essays and writings. And in the same way, programming is just one tool in the bigger area of computational thinking. It's the same as if physicists where to use prisms, or chemists where to use pipettes. And we need to get more kids who don't have this natural affinity towards computers to see programming as a tool for self-expression, as the modern-day Legos, as the modern-day Crayolas. Because I was this little girl. I had no interest whatsoever in computers growing up. And I talk about little girls here, but please feel free to sort of replace this whole thing with any other minority or a group of people who don't naturally gravitate towards computers. Little girls, they don't know that they are not supposed to like computers. I loved French, philosophy, art, coming up with imaginative storytelling and so forth, and I never thought that the cold world of machines and logic would be a place for me. But little girls, the future little girls, they are going to be different. They are precise, they know how to concentrate, they are really awesome at asking the questions, what if and why and how this works, and they don't know that they are not supposed to like computers. So I figured, how should then computing or coding be taught to these kids? And I came up with this list of topics and tools and practices around computational thinking and programming. And I figured that many of these things are things that you can actually learn even before you learn the term. So before you learn what an array is or what an if-else statement is, you can learn about the idea of selection, or you can learn the idea about repetition. And in some ways, planning a three-course meal is like planning an algorithm, or in some ways our years are full of little loops of a sequence of 7 weekdays, and then you repeat them 52 times. And whenever we give a route from place A to B, we are in effect decomposing a problem. And one of the big problems I saw in this world was that there's two types of pleasure in programming. And anytime I spoke with programmers, they kind of, in some ways, showed this to me. There's the type of pleasure, the more intellectual pleasure of I don't know, solving a very hard theoretical problem, or writing code that is logical and beautiful and resonant. But then there's the more almost physical kind of joy of fiddling around and falling over and eventually making the computer obey your will. And that's called play. And that's the side of programming that I wanted to bring out. Because as a little girl who learned philosophy, I loved Bertrand Russell and his formal logic that eventually found its home from the computer. I loved conjugating French verbs, which requires a lot of pattern recognition skills and abstraction skills. And I loved knitting, which in a sense is symbolic representation full of selections and sequences and repetition. So it totally does make sense for a little girl to get excited about computing. We just need to come up with a new way to teach them. So I went to the very best of people in the world of play, namely the Sesame Street. And I spoke with the Sesame Street people, and they said that 3 things that made them special back in the days. They were really revolutionary in the 60s when children's television was totally new. No one had done anything like what they were anticipating on doing. And they said that fun is paramount. You need to make education fun, otherwise kids won't do it. And then they were absolutely rigorous in A/B testing everything. Before there was a term called A/B testing, they already tested all of their content with kids. And then they involved the universities, the researchers to develop their curriculum. And they say that play is one of the things that affects most of our behavioral, our cognitive, our social well-being and learning. And another company that is famous for their approach in play is Lego. And when adults think about play, we oftentimes think about games with rules, but Lego says that no, there's actually 5 types of different play things. There's physical play, there's play with objects, there's symbolic plays, and there's pretense and socio-dramatic play. And they went even on further, and this is all from Lego Foundation research, to sort of map out the different motivations of play. And they say that there's the achievement-based motivation, there's social-based motivation, then there's immersive motivation. And when we, as programmers, look at this list, we as programmers who get to play in the best scenarios all day long with our code, we can recognize a lot of things. We can see there's self-disclosure, finding and giving support, there's exploration, there's collaboration, there's even escape from real life. The problem is, oftentimes, we only teach these things, progress, power, numbers, optimization, when we start to seriously teach kids about coding. So one can figure out a system where you could be teaching all of these things. And I came up with 3 things: my principles of play, playfulness, rules, and curiosity. And let's start with the first principle, the principle of playfulness. And it starts with asking the question, what if? What if something happens? And it starts with little Ruby. She's, as said, 6 years old, completely fearless, stumps and stumbles around the world and sees all this colorful side of computing. Because when I talk with people, layman people, normal people who don't touch computers, they say that programming is such a silent thing. The programmer, they sit in front of the computer and the breakthroughs are absolutely silent. Nothing happens. They just sit there tapping the computer, and all of the culture and colorfulness, all of you know so well, is hidden in the murky underground internet forums. So Ruby's here to sort of bring all of that out. And if you tell Ruby to change clothes for school, she will do that, but she will leave her pajamas on because you didn't explicitly say that she needs to take the pajamas off. And if you tell Ruby that she needs to clean her room, she will do that, clean her room out of all the toys that are lying everywhere. She will do that, but she will leave the papers and pens on the floor because, hey, come on, papers and pens are not really toys. And Ruby, she has this dress code thing. She's very, very, very particular about the rules she wears, the clothes she wears on each day. So on Mondays, she wears only clothes that are red and green. And on Tuesdays, she wears clothes that are yellow or green. And on Wednesday, she wears clothes that are not black. And little Ruby, most of all, she understands that sometimes big problems are small problems stuck together. And that bugs, they do exist. They live under your bed. They have infinite loopy tails and pointy teeth, but you're not supposed to be afraid of them. The second rule is the principle of, starts with the question, how? And one of the things I dislike about our modern world is that we teach kids how combustion engines work. We teach them how babies are born, but when they ask about computers and how they function and what are the rules of the computers inside, we just say that, oh, it's a black box and don't touch it and don't tinker with it and don't try to make it any better. And that's what programmers do every single day, and if we sort of don't give kids that experience, they don't have any idea of the rules that exist. Asking the question, how? So Ruby, she knows that when you bake cupcakes, you need to have a sequence of orders. And then you can, if you abstract correctly, you can group the different sequences of orders into different kinds of groups in order to make different amounts of cupcakes or different kinds of cupcakes. And she's really good at spotting patterns, repeating patterns in snow leopards, wallpapers, and finding the truth about the different bugs. She can pair different bugs together, and she's really poignant in describing her friends. The last principle is one of curiosity, and the one that I find is the most important, and it starts with asking the question, why? As I said before, it's funny when you think about parents and adults and us today. We have forgotten the past about computers and the poetic and pragmatic nature of them. We teach our kids how a combustion engine works, how the human body works, how to become an astronaut, even in Finland where we've never had an astronaut before. But when kids come to me and ask, Linda, what is a bubble sorting algorithm? And Linda, what actually happens when I press play on YouTube? And, Linda, is internet a place? We adults, we grow oddly silent. We mutter something about it being very complicated or it being magic. Well, it's neither. It's not magic and it's not complicated. It all just happened really, really, really fast. And computer scientists are among my favorite people on earth, but the thing that they've done, they've built abstraction and layers and layers upon abstraction in the past 20 years to shield us, normal people, from the computers to the point where we have no idea what a computer actually is anymore. So with the kids, we start from the very basics. We start by talking about what is a computer. So I show them 4 pictures, and I show them a picture of a car, a dog, a grocery store, and a toilet. And I ask, like, which one of these is a computer? And first the kids, they sort of project their parents' ideas about a computer and say that, no, a car is not a computer, and a dog is an animal, it's not a computer. And then we talk a little bit further and realize that, oh yeah, like there's a navigation system in a car, and maybe a dog is not a computer, but maybe the collarbone can have a computer, and maybe in the future a dog can have a computer inside of it. And we talk about grocery stores and how in the past computers were so big that they couldn't fit into this room. And when these kids grow up, computers are probably going to be so tiny and small that you can fit them inside each milk bottle. And then the eyes of the kids light up and they start to come up with amazing ideas what computers can do. And the favorite thing of all is the toilet example. I tell them that kids like in Japan, even the toilets are computers. But the more important thing is that we built our first computer. It looks like this. Oh, wow. So it's a tiny computer, and they learn about the BROSI processor that lives inside of it, and they learn about the helpful RAM, and they learn whether summer vacation pictures go to under the hard drive and what happens if you drag a virus inside. And most importantly, they design their first own application for their computer. And I had this little boy, 4 years old, called Arthur, and Arthur loves Legos, and he has a ton of coloring pages his mother has printed out. And he designed a little button that allows you to print out these coloring pages. But he wasn't happy with that. Pretty soon he felt that, why should I print coloring pages if I can print Legos? And he went totally wild and started printing out with his paper computer, all sorts of home appliances like a toaster and stuff like that, and even the family breakfast next morning. And the mom was a little bit hesitant, saying Arthur, I don't think that's possible. But I told Anna that, no, that's totally possible. When Arthur grows up, he's probably going to be printing his own Legos. And then I had this little girl, she was 6 years old, her name was Ada, and Ada wanted to be a dolphin doctor when she grows up. And she didn't really feel computers were her thing. But we talked about it, and eventually we realized that maybe Ada, as a dolphin doctor, will need a dolphin health patients application thingy. And she designed it herself with the little pictures and the stats of the health things and so forth. And she was a very proud future dolphin doctor. But maybe my favorite story of all time is the story of a little boy, Tommy. And Tommy loved playing an astronaut with his father. So in Tommy's world, he had his little laptop, and he had these big earplugs or things on his head. And the father was the astronaut. And father is on the opposite side of the room, and Tommy sits here. And Tommy's role is to guide with his self-made intergalactic planetary observation application, the father safely home from the Martian orbit. And these kids are going to have a profoundly different experience about technology because their imagination has been sparked. They haven't been told that, no, you can't do this is not possible. They will have a more playful and imaginative journey through the world of programming. Finally, none of this is really new. I think our industry is super special in the way it's treated children and possibilities in the past. Already Alan Turing, who made marvelous other things, one of the most fascinating concepts he came up with already in the 50s was the idea of a child machine, which in simplified terms, he said that what if we start to teach artificial intelligence the same way as we teach children and learn about the patterns and ways kids play and learn in order to make the computer learn? And then Seymour Papert, bless him, came up with this wonderful research paper called 20 Things You Can Do with Computers in the 70s, where he said that kids should be able to produce things and create things on a computer instead of only calculating the root numbers of 21st prime numbers or so forth. And Alan Kay, if you haven't read this, this is an amazing piece from the Xerox PARC era, where he basically describes a hackable iPad for kids in the 70s. And software and storytelling, they have a long road together as well. Here's a bunch of books that really influenced me, from Eric Weinstein, Jeremy Kubica, and Carlos Bueno, chapter books maybe for a little older kids who already read themselves. And then the book that brought me to the world of programming. I don't think Wise Poignant Guide really taught me anything about programming, but it showed me how much imagination and wit and warmth and colorfulness there is in the Ruby community, and it made me care. And that's why we need storytellers. When I talk with people, and I talk a lot with people who are not programmers, the perception they have is computers write code, and computer languages are written by computers. And I tell them that no, that's not the case. Code is written by humans for other humans to read and modify, and then computer just executes the orders. But code is like inherently a human thing, and the very DNA, the atomic fabric of internet is humanity. And in the past, computers were people who were really good at calculating things. And technology as a word, in the Greek era, it used to mean not only the skills and the tools and techniques to get something done, but also the skills and competencies of the humans building these things. And that's why we need storytellers. When I was small, I wanted to be a world builder. I wanted to roam. I wanted to wake up in the morning in Moomin Valley. I wanted to roam around Tatooines. I wanted to go to sleep in the Narnia world. And no one told me that I couldn't ever graduate to become a world maker. But I found a loophole, and that loophole is programming. Because programmers, you guys, you are the storytellers of the universe. And out of nothing, you can create entire universes with the pure power of words. And that's all I have today. Thank you.